Welcome to this final session of today here in the net zero area of this exciting conference. Now, we've talked about very many different aspects of life and how they might change, how they need to change, and how Wales might grow and benefit as a result. Now we're talking about transport. Yes, green trains, planes and automobiles we're talking about. So you can see from that title that we're looking forward, not talking about the problems of what we have now, but what the opportunities are in the future. And in fact, transport accounts for 20% of global CO2 emissions. So that, if nothing else, is one really good reason why we should focus on this for the next half an hour. I really look forward to questions, both online and from you in the room. And I have a fantastic panel with me. I have Carol Featherston, who's a professor at Cardiff University and a leader in sustainable transport. Andy Doherty, who's Chief Technical Officer of the Global Centre of Rail Excellence. That's in Ontloyn, sort of, how do we describe that? The top of the Neath Valley, let's say, and had a lot of money, £80 million. So it'd be nice to hear about that. And Christian Burton, who's Field Application Manager at CSA Catapult. Now, if anyone was in the compound semiconductor conversation that we had yesterday, this is about compound semiconductor applications, I think. So let's start, first of all, with you, Carol. Do you see this as an area of huge change? Because I see it like that, but tell us where you think the exciting change will be.
I'm going to see if this works. Oh, yes, it is working. Okay, so yes. As you mentioned, I'm looking at sustainable transport, but particularly focusing on aerospace. And that is going to have to change significantly because of the, obviously large power consumption of aircraft and the fact that we are going to have to really look at completely changing the fuel that we fly with. Electrification, which is obviously going to be a big part of decarbonising road transport, it is simply not going to work for aerospace other than short-haul flights. So we're going to have to look at some very different solutions. And because of the size of the shift, I think it's really going to have to be, and we do see this in other areas as well, a kind of two-stage shift. So kind of initially, we need a solution that we can be applied kind of from now, which doesn't require us to change everything. So at Cardiff, we're looking at sustainable aviation fuels, which is basically biofuels. And the attractive thing about those is that they will significantly reduce the carbon emissions. But they're what's called a drop-in fuel. So it means that we can operate them with the same aircraft that we use now. We can use the same systems in terms of supplying fuels. But long term, we will need to look at another option like hydrogen, and that will be a significant change in completely changing the design of the aircraft. The storage will be different, the supply will be different, but also then working out how to get that hydrogen to the airport and onto the aircraft and how to store it, and lots of issues to do with how we do that.
Well, yesterday during the discussion about compound semiconductors, we heard about tiny solar panels on planes, for instance, so we could have solar-powered planes. You mentioned the hydrogen. I mean, that's quite a way forward, and I'll pick that up with you in a second. And then, obviously, you were mentioning hydrogen. We also actually have companies already investing in Wales, don't we, looking at low-carbon fuel for aviation, like LanzaTech. So how quickly do you think people will actually begin to see these changes? Or is it such a big jump that we have to wait and then make a big jump?
Yeah, I was actually listening to a talk by Airbus this morning, and they were saying that within the next 5 years, they want to get 50% of their aircraft running on 50% mixes of
within 5 years?
Yeah, yes.
So, I mean, that's really quite rapid, isn't it?
Yes, and that's one of the really attractive things about them. But I think with all of these fuels, there's obviously questions around the technology of using the fuels in the aircraft. But there's also huge issues, and I think Andy might be talking about this in relation to electricity, but just actually how do we make the amount of fuel that we're going to need?
Yeah,
because
exactly.
we've been set up for so long to run on hydrocarbon fuels.
Yeah.
And, you know, there's statistics like the amount of green electricity that we are currently generated would supply 80% of the needs of Heathrow Airport. And that doesn't count any of the other airports or any other kind of forms of transport or heating or anything else that we need to use electricity for. So I think this is one of the huge challenges.
One of the big challenges, how we're going to do all this. Okay, well, I think this is a good point to bring you in, Andy, because as I mentioned, we have the Global Centre for Rail Excellence. I might have had those words in the wrong order, but you know what I mean. £80 million. Interestingly, Welsh Government and UK Government working together on this. And, you know, take us back 5 years ago, we probably thought future rail meant electric. But it's more complicated than that, isn't it? Tell us what you're doing.
Right. So GCRE, Global Centre for Rail Excellence, as you rightly said, is a large test centre that we're building at the top of the Delice and Swansea valleys. So it's sort of the heads of the valley, the west end of the valleys. It's 700 hectares of land on a brownfield site. So there's two things we're trying to do. One is we're trying to build the site as much as we can at low carbon, at sort of neutral carbons, recycling as much as we can. We're trying to build it net zero as a site in itself. And then, having built it, the purpose is to then enable the railway to move forward. It's already, on one side, the most efficient and sustainable railway in the sense that transport system, in the sense that it's steel wheel on steel rail, so very low adhesion. What its greatest asset for adhesion, for sort of efficiency of energy, is actually its worst asset in terms of braking. So we always have the problem of the wheels sort of leaves on the line and things like that in autumn, which is the major sort of drawback for railways. Now, the whole purpose of the centre is actually to test new technologies, to test composite overhead line systems that are aesthetically pleasing.
Okay, can I pause you there?
Yeah.
Composite overhead line systems.
Yes.
Can you just de-jargon that for us?
Well, and many people here will have travelled on a Great Western train from Paddington to Wales. It was electrified at ridiculously great cost. If a nuclear war ever happens, the one thing that'll be standing is the electrification system. Huge steel masts everywhere, battleship grey, really looking good in the environment, don't they? Not particularly attractive, are they? And grossly over-engineered. Wouldn't it be nice to build it out of composite materials, low carbon materials?
What composite materials are we talking about?
Well, generally speaking, it wouldn't be carbon fibre, because carbon fibre is a conducting material, and the one thing that a composite material that's non-conducting is very attractive when you've got a very large high voltage system like 25 kV over it. So the ability to shape and form and colour a system like that, such that it blends into the environment but actually provides the function of keeping the wires up in the air, is a good example.
So just to make sure that we're all kind of up to speed without making any pun on this, you're talking about testing new types of electric trains. It's electricity that you're seeing the trains as being.
That's just one example.
Are you also testing hydrogen trains?
Yeah, we'll be testing hydrogen. We've made a large provision for hydrogen storage on the site. We'll be testing batteries. We'll be testing biomethane. We'll be testing all sorts of different fuels. We'll be testing different materials. And the uniqueness of the site is it actually is testing infrastructure. So the interesting thing that you mentioned, hydrogen, it's one thing to be able to have the hydrogen to provide the motive power in a plane, train, car. Storing and moving hydrogen is a non-trivial subject because it fossilizes the metal, that you store it in. The whole process of engineering the airport, engineering the depots for and creating the hydrogen filling station is non-trivial, not fully completed yet, not for cars either. And when you look at every day, millions and millions of people filling their cars up, the number of fuel operations a day must be tens of millions. Repeating that with hydrogen, non-trivial.
Okay, fine. So, but let's keep just to rail for a moment. So the rail sector as a whole hasn't decided which future fuel it will focus on. Or, it might not just be electric.
Well,
because obviously we've got electric and diesel at the moment. We're not going to have diesel.
The electric solution is the perfect solution.
Right.
Completely electric.
So what will question that then? The amount of electricity that we can generate?
No. In terms of electric power of trains, about half the railway in the UK is electrified and about half isn't, so it's diesel powered. Actually, to put electric overhead line systems around the rest of the country, we couldn't afford to do so. There's no business case for doing that on a regional railway, for example. So the business case will be composites of hybrid power, whether it's battery electric, whether it's hydrogen electric, whether it's biomethane electric. Fundamentally, the railway's already electric. Every diesel train you see actually has electric motors on it.
Yeah.
So it's actually about what provides the motive, how you convert your energy into motive power.
Right. Okay. And compound semiconductors are absolutely vital to this, aren't they? Because, they're the things that can help technologies become super efficient in simple terms, yeah?
Yeah, exactly that. Simple terms is always difficult with compound semiconductors because they are really in the weeds of the electronic stack. So we start off with a kind of a very thin plate of glass, which is our compound semiconductor. It is then patterned and doped as needed. With this very thin sort of dinner plate size piece of compound semiconductor is then diced. And that's when it starts its journey into something that might be more recognizable as electronics. So then it goes into a package, which is the sort of little black components that have the little metal legs sticking out of it. And then it goes into our systems. Hopefully that's kind of brought everyone up to speed as to roughly what we might be talking about. Why compound semiconductors are interesting is because there is a physical limit to the electron mobility in silicon. Which is what everybody's been using to convert different from DC electricity into AC electricity, which drives motors. So it forms that essential part of the traction train. What we do at the compound semiconductor applications Catapult is we match the end output, what you desire. So the electric machine we're trying to drive, which might be something like a rail machine. It might be as interesting as hydrogen-powered aircraft. So they still exist in those alternate fuel lines. And then we look at the frequency, the power load, the cooling load, the rate of change of the system, and then we tie the whole system together as a full stack of components and then put that out into an end application.
So Carol was talking about the demand for electricity, and of course, actually, the demand will be for renewable electricity, won't it be? Not for electricity from other sources, massive increase. But you can help in that, can't you? Because you can make the use of electricity more efficient. So there's a kind of partnership here.
Yes, absolutely. Across all the fields. Very much as a train is trying to accelerate, as a plane is trying to accelerate, they're using power. If it's an electric drivetrain, the efficiency of that will be 100% determined by, not 100%, 100% of the power will go through our compound semiconductors, which currently are the most efficient solution out there. So that's really exciting. But also there's a second gain in that as the system starts to try and bleed power, it will be able to go into generative mode. So you can start to harvest some of the energy that you spent back, making the solutions even greener. And then the last place that they can help is the size, weight, and power of the system, so the weight element of it. Within a lot of these systems, you have passive components, so big capacitors that are hidden away somewhere on the aircraft or in a car, and we're able to reduce the size of those. So the actual kind of the carriage weight goes down as well. Not so much carriage, say car weights go down as well, and then that really allows a kind of a virtuous cycle. Because the weight is decreasing, then particularly batteries can shrink. It's real beneficial to the system.
I think in terms of the conversation, in terms of net zero, I don't know what you guys think. And by the way, this is a shortish debate, so feel free to put your hand up and join in at any point. We'll get a microphone to you. But one of the things early on, Carol, is, people were saying things like, oh, does that mean I can't go on holiday? Can I not go on that stag do in Berlin? I'm not going on a stag do in Berlin, but, just as an example, are we going to have to stop flying? And that's kind of politicized it a bit, that kind of language. What seems interesting is that you seem to think that we're not going to stop flying. We'll just fly in planes that are run differently.
Yes. Yes. So obviously that's a question that's being asked.
I mean, you could say perhaps we should do a bit of both, but hey ho, that this is a few minutes focusing on transport, not on lifestyle.
Yeah.
But you do think it is going to be feasible, because we'll find a solution to lots more electricity, won't we? We'll have to.
Yeah. I mean, that is the target of the aerospace industry. Given the fact that there is, projected for more people to want to fly. I mean, there are lots of people who don't fly, various countries where people haven't traditionally had the finance.
Even in the UK, the majority of people don't.
Yeah. And it would be, so in making this transition, we have to make an ethical transition as well. It has to be fair. And I think it's another one of these areas where we can't say, we've done it, we've created all these emissions, but now you're not allowed to do it because we've realised it's not good. So all the, the targets and the advances are being made with the expectation that we will need to have more flights, more passenger miles, but we need to reduce emissions at the same time.
So what does the aviation industry need from policymakers? I mean, really, it's UK government in this role, isn't it? I mean, what do they need? Quicker decisions, better subsidies? I mean, what would you say they need to do?
Well,
no, go on. Yeah, go on, Andy. No? I didn't think that was a poison
chalice. Do you really
chalice.
want to be provocative about this?
I'm just picking your brains. That's my
Wouldn't
role.
it be good if we had competent politicians? Because they don't understand technology. They don't understand the issue that they say, oh, we want to be, going green. So by 2030, what was the government promising? That we're going to move all, to renewable power, and renewable power sort of would be a large percentage of it. You go and talk to the grid right now, as I am, and say, please, could I have a connection to the grid system because I can put 70 megawatts of power, renewable power on my site. They will say to me, or they have said to us, well, your connection we could probably give you in 2033, 2036. There's no chance of an earlier connection because nobody has actually thought about planning the grid system. When you're changing from fossil fuels to electrically powered, fundamentally powered, whether it's powering the hydrogen, whether it's creating the hydrogen, whether it's powering electric vehicles, whether it's a car, a train, or an aeroplane, it doesn't really matter. You need lots more electricity. And there is no long-term plan.
No, but that's why people are talking about different systems of grid, haven't they? And localised grid.
We're all having to find solutions
it's changing, isn't
that are suboptimal to the major problem.
No, but we've got to find solutions.
Yes, and we also need policy process in government that encourages and develops the country to enable that to happen. And if we don't get politicians to start looking at that long term, we're all doomed.
Okay. I don't want us to be doomed. I'm not suggesting it's trivial at all. I mean, this whole area, Christian, of how we generate more energy, how we use it most efficiently, and what we focus on, let alone entering into the ideas of our homes being little power stations and things like that. It is a very fast-moving world, isn't it? And it's one that compound semiconductors are playing quite a different role in different places and different aspects.
They're absolutely everywhere. So, I mean, the most common use case people will be aware of is their phone charger. The technology that's in them is phenomenal. In terms of the benefits that be provided by the latest generation, we're seeing something like 10 to 20% change at wafer level. So before we get into the electronics, in those components that can't be avoided, we're seeing 10 to 20% change in something called the RDS on, which is essentially how much energy you lose as the device is operating. And that's year on year. So we saw something at 20 milliohms, we saw sort of 16 milliohms, 13 milliohms, and these numbers really mean hours that the grid is working as hard as it could, versus as we start to introduce these alternate materials, improvements in range, improvement in terms of heat loss. So yeah, real environmental impact.
And it's developing all the time, isn't it? As you use different things like gallium nitrate and all these different things that are changing, the elements are changing, aren't they?
Yeah.
What I think is really interesting is that your sector is not only making the power generation more efficient, less lost in transmission, but it's also then being involved in the product at the end, be that an aeroplane or a train or whatever. Is it also still an industry in itself that is getting faster and faster? Like, we heard yesterday about improvements in efficiency. In 5 years' time, will those improvements of efficiency be even more, would you expect?
Absolutely. So we do a lot of work within the automotive sphere. So we work with some excellent partners like McLaren, BMW, Microchip, Mercedes, YASA. And what we've seen is the development life cycle is typically actually about 5 years or so anyway. So from thinking about a product to actually getting something at a decent level of volume takes about that long, simply because you have to have early prototype, you have to have a gateway, you have to then try and get production size tooling, and that takes as long as it takes. So the idea that this will still be happening in 5 years' time, I think, is a certainty. Do we think that the systems are going to become more special purpose around the use case of full electrification, and around really taking these compound semiconductors to the limit? Yeah, I don't think there's any doubt.
And Carol, as an industry then, the aviation industry still hasn't decided in a way which horse it's going to bet on in terms of future energy sources. Is that right?
Well, the Aerospace Technology Institute's recent reports started off analysing different fuels and energy densities, and they came to the conclusion that hydrogen was likely to be the fuel for medium and long-haul flight, which is about 80% of the flight miles.
So is medium Europe or is medium further than Europe?
It would be some of the further places in Europe.
Okay.
They're not going to Paris, maybe, which is about the same as going to Scotland. But yes, so and that's a large majority. Airbus have also said that they are going to hydrogen for medium and long haul.
And
flights.
Have they talked about timescales yet? Just rough timescales, no?
Yeah, so that I was mentioning earlier that it's kind of like a two-stage. So a lot of companies working in the aerospace sector are looking at, say, a stage gate at 2030, 35, which is to implement the kind of stage, like, for example, implementing sustainable aviation fuels, and then 2050 for the more significant changes, to give time to develop those.
And already they've tried to make themselves lighter, haven't they? The wings, for instance, made at Burton are lighter because they're not made in metal anymore.
Yes.
So they've tried to save fuel, and now they're having to change fuel. Is that the kind of dynamics?
Yeah, absolutely. And I was going to mention, because we've been talking a lot about fuels, but obviously I think in any form of transport, we need to look at the whole system. We need to do everything. If we just do any one part, we won't get to net zero by 2050. So, we need to look at system efficiencies. We need to carry on with our lightweighting. So, since 1970, we've reduced the amount of power per passenger mile down to 60% of what it was in 1970, and we need to keep doing those things. So at Cardiff, we've been working for a really long time on structural optimisation. So that's basically taking things like the wing structures and saying, how can we use less material in them? And things like novel manufacturing processes, like additive manufacturing, are allowing us to make even more unusual shapes that allows us really to kind of think about where do we need to put the material, what kind of shape does this need to be in order to reduce the weight as much as possible. And then obviously there's been a big shift in the aerospace sector to using composite materials. You mentioned composite materials either. So these would mainly be carbon fibre, epoxy resin composites. So those are have much better specific properties, so they're much stronger and stiffer compared to their weight.
Yeah.
But then that gives us lots more challenges. So a couple of things we're working on at Cardiff is one. So if you have a metal aircraft, an average aircraft, not to worry anybody, gets hit by lightning on average once a year. But when you have a metal aircraft, it's like a Faraday cage. So it conducts the electricity, and it's fine, as we've seen, because they've been flying for a long time. When you change to composite material, that's not the case. So obviously we've had to find solutions to that. So a lot of the composite aircraft that are flying at the moment, they have a copper mesh that's integrated into their structure that conducts electricity instead. But that makes it, that has a weight, which is exactly why we've changed to composites.
Right.
So we're looking at kind of what is the lightest weight solution to mitigating.
Yeah.
So all of these things.
Are any hydrogen planes being tested at the moment? Because I thought there is one, isn't there, in North Wales?
There are some.
But
Yes.
you can't talk about it. But it's that it might possibly be the funny shaped one that takes off from North Wales. Okay. Anyone? Nobody's put their hand up, and you're going to run out of time to have the opportunity to ask the question. Oh, there is a question. Fantastic.
I think in France they've stopped short-haul flights and very much putting the emphasis on rail. Is that one of the ways forward, that there's an integration between the use of rail and aeroplanes, so that actually the greenest aeroplane is a train?
I think we did that one to Andy. In France, they've stopped long-haul flights.
Yeah, they have.
2 hours.
There is a number of initiatives, particularly in the European Union, where they're saying less than, well, at the moment in France, they said 4 hours, but I think they want to bring it down to 2.5 hours. So if the journey is more than 2.5 hours on a train, then you can fly. And if it's less than that, then you have to go by train. So you're killing off the sort of very low, short haul commercial airliner. Because if you look at the stats of, say, Eurostar that publishes numbers, the amount of carbon used is about 50 times less, assuming that the plane and the train are full. You get into that very interesting thing about, is the car, is the plane, when's it full, when's it not full? But a train is certainly very efficient in that. Can it sit there like that? No chance. It's got to move forward. It's got to get better and better on that, and then have the debate about where the energies are coming from. And the only thing I wanted to say is that we're all notoriously slow. Aircraft industry, safety, all the sort of things involved in it, railways, they're all slow to innovate. The IT, the technology sectors are much, much faster. We have to find a way of going faster. So one of the reasons why I'm doing what we're doing is that we can accelerate technology change in the railway. And that has to happen in partnership with universities, which we're partnering with Cardiff and other universities. The aerospace is doing that as well. And it's a non-trivial challenge that we all need to live together, work together to find the solutions to make it happen.
Okay, so just to throw ahead for us to finish, what will a train in Wales look like in 10 years' time? What will it be run by? How quick will it be?
Well, around Cardiff, around the South Wales
We don't all live in Cardiff,
it's all going to be electric. Around the sort of Mid Wales to North Wales, well, if we believe Rishi Sunak, we have electricity on the North Wales line. Don't hold your breath on that. I think it'd be
What
more
about
like,
the trains, though? They're like cattle trucks.
They'll be hybrids.
Okay.
Probably battery, diesel, electric hybrids initially, then probably hybrid to hydrogen to electric after that. in 10 years.
Right, okay. And you guys will be still continuing to make everything as efficient as ever, yeah? Or even more efficient. Do you want a final word?
Definitely. Something we were talking about in the green room actually is the pace at which innovation is able to be fed back into the ecosystem, so that we actually realise the possibility of these, say 5%, 10% improvements that could just be power we don't ever have to use. And I think one of the things we try and do inside the Compound Semiconductor Applications Catapult is speed the time of qualification and pre-qualification of these, so that you can get better technologies into end applications faster, which I think is really needed and really not a trivial subject at all.
Fantastic. Thank you very much. Thank you to all of you, to Christian, to Carol, and to Andy, and to you. Let's give them a round of applause. Thank you.